Hello, everyone. Here we are in the final moments before this next talk is going to start by Lætitia AVROT. And she's going to explain how PostgreSQL can or can't compete with analytics specialists. She's going to analyze the analysts. So let's give her a hand of applause and listen.
Hello. Before diving right into the subject, some housekeeping item. So if you've already been to one of my talks, I always create 2 slide decks. Why? Because the first one has no text or so little text. And the second one, the one I share and the one you can find here, is with text. Why did I remove text from my slides? Because I found out that when there is text on slides, people are reading them instead of listening to me, which is infuriating because I'm a mom. I have to be listened to. So for whatever reason you need to get the slides with text, they are here. They will be posted on the website of the conference. And here we go. So my name is Lætitia AVROT. I'm a PostgreSQL DBA since 2007. I'm a PostgreSQL recognized contributor, former member of the PGEU board. I was the treasurer. And I'm the founder of Postgres Women. And until recently, I was a university teacher in Lyon. And I'm a PostgreSQL consultant. You might find something that I write on my blog, mydbanotebook.org. So I began that blog because, you know, when you find something and it took a lot of time to find, and then you forget about it, and then you need that information again. So that's why I wrote my blog. And also I created this small website, psqltips.org. It's a website that will give you a small tip about PSQL at random. We have 150 tips at the moment. The main goal is to go up to 300. I did that because PSQL is the only official client of Postgres, and it's underused and undervalued. So I wanted to show how good it was. So, do you need something else for analytics? The short answer is it depends. This is a running joke we have when you're a consultant. Each time you ask a consultant a question, the answer is always, it depends. And the long answer is this talk. But before diving into analytics, we need to understand how Postgres stores and processes data so that we can understand the differences with analytics specialists. So first, let's dive into the heap file. The heap file is where Postgres stores data. Each file is meant of several pages. Each page is 8 kilobytes long. So we have in each page a header and then tuples, dead or alive, and some free space. On the last page, or even in the middle, we have some free space. And each file is a maximum of 1 gigabyte. So if you need a new file, then we will create another one that will be numbered. So what's happening inside a page? So this is a page, so at the beginning, you have the byte 0, page start. At the end, you have the, oh, I could use that. Yes. So at the end, you have the 8,192 byte. And then you have a header. The header is made of several things, including LSN here, the checksum, and here you have a pointer to the lower level of the pointers. So it's that here. And then you have the upper value of the tuples here. And then you have something special only used for indexes. Each pointer here will point to a tuple. So that's how it's done in Postgres. And you see that each time you have complete tuples. So it's a row-oriented storage. For MVCC, you know the X-min, X-max, and so on. So those, normally on a transactional load, that's not very important overhead. But where you're doing analytics and you're processing 100 million rows, then that's 2.3 gigabytes of overhead just for transaction management. So yes, we have MVCC, we have transaction isolation, we are able to do rollbacks and so on, but there's a cost. So this is how Postgres creates a sequential scan. So he needs to scan the whole heap file. For that, he will look at each page. He will read the page. He will scan the line pointers, the one we've seen at the beginning of the page. And for each line, then he will check MVCC. He will go to the visibility map, making sure this tuple is visible, and so on. He will apply where filter, and either he will return the row or skip the row, and it will repeat. So this is a very brute force approach, because it's scanning everything. But sometimes it's better it performs better than going through indexes, in particular if you want to get a lot of data. Then we have index scan. So index scan is only possible if you have indexed the columns you're using, obviously. So you can use an index when you have indexed column in the workloads, or even if you have only indexed column in the select clause. So here, the index scan, we scan for matching key in the index, and for each matching key, we get what we call the TID. The TID is the page number where we will find the row, and then the offset, the byte offset, where we will find the row in the file. The pointer of the row. Then we access the line pointer array, remember, at the beginning of the heap. We will read the tuple from line pointer. We will still need to check the MVCC visibility, and then we will apply remaining filter. So you see here, all that part is still accessing the heap. It's faster because we go directly to the pointer than to the tuple, but it's still accessing the heap. So it's still accessing the whole tuple, the whole row. Then we have the bitmap scan. So bitmap scan is kind of a middle ground between doing a sequential scan and an index scan. The idea is that instead of reading and for each matching key of the index going to the heap file, we will try to collect them and go to the heap file to collect all of them at one go. The idea, so here you have the index scan. Yep, where is it? Yeah. So you have the index scan here with the TIDs you found. You read all the matching TIDs, then you build an in-memory bitmap where you will say, there is something on page 1, there's nothing on page 0, nothing on page 0, something on page 3, and so on. And so you will only read the pages where you know you will find data. It still means you will have to read the whole page, but you will skip a lot of pages depending on the selectivity of your query. You can combine multiple index using that technique with bitmap and bitmap or. So that's something you can find in your explain plan. And correlation does not matter to use bitmap scan, so that can be very efficient. So let's say we have some very basic analytic query, select some amount from sales. We'd like to see how much we sold. And then Postgres will process each row and each page on each row It's reading 100% of data, but it will only use 10% of columns because we just need the amount column. For example, here, if we have a 100 million rows table, and each row is an average of 200 bytes, that's a 20 gigabyte table, which is not that impressive. The query needs only 8 bytes from those rows, because it's an integer column. So we need 800 megabytes, but we will read the whole table, so 20 gigabytes. That's a 25 time overhead, which is not that good. So my conclusion is PostgreSQL architecture is not meant for analytics. But we had some improvement with PostgreSQL 18. So the first one is called IO Uring. Has anyone heard about IO Uring? Yeah, that's one of the great features of Postgres 18. So the idea is that before, Postgres was reading page 1, waiting, processing page 1, reading page 2, waiting, processing page 2, and so on. So the total time was the sum of the wait plus the wait time plus process time. Now, it reads page 1, page 2, page 3, wait for each of them, but process the pages as they come. So the total time is the maximum wait time plus the process time. So it can help a little. So it helps on sequential scan when we read very large tables, obviously, because we will read a lot of pages. It's great for fast storage, where you're not IO bound. And it's also great when data doesn't fit in cache. But if your data fit in cache, I'm pretty sure it's not an analytics problem. So normally, you should be OK. So IO Uring makes IO faster, but we're still reading the entire rows. It does not change how we store rows, and it does not solve that problem. And just to use IO Uring, you can set IO method to IO Uring in PostgreSQL.conf. Then we have the B-tree skip scan. So before, when you had an index like that, so on region date product, if you only query on date without region, it was not able to use the index, because you need to use the index. If you wanted to use the index, sorry, you should have to inverse sales date and region. If date is the first column, then you can use it. Now, what it will do, it will search for each region. I'm very sorry. Very sorry about that. Can I get a glass of water, please? Thank you. So for each region, it will look in the index for the value. OK, so here is how it works. For region Asia, it will find the right value. For EU, same thing, and same thing for US. So for each distinct region, it will do a binary search for date. This is only efficient if you have a few number of regions. I guess we can keep doing now. So that's something you can use, because it's very important for you, because you can remove a lot of indexes, because now the order does not matter that much. It still does matter. Then we have parallelism in PostgreSQL 18. So Gene indexes can be built parallelly, and we have better parallel query optimizer, including better group by parallel workers, smarter decision on OR clauses, and improved window function parallelization. So all features that were already good for Postgres 17, but even better for 18 and useful for analytics. So, as I said, PostgreSQL 18 is great, but it was not designed for analytics. What did others do differently when they wanted to design something for analytics? So, let's talk about ClickHouse. So ClickHouse is an open source columnar OLAP database with compression, very fast query execution, and it's designed for analytics. So what do I mean by columnar OLAP databases? It's meant that instead of storing the data by row, as Postgres does, it will store them by column. And then it has some interesting data structure. When you insert data into ClickHouse, it will create something that is called ports. And those ports, later, will be taken by the background process and merged into what they call merge parts. Those merge parts are compressed and optimized. This is an LSM3 style. So it enables fast insert without rewriting the entire table. But it's not for free. Updates are complicated because when you insert data with part, as we've seen, when it's merged and so on, when you want to update data, that's difficult. Also, ClickHouse prioritizes analytics over transactional guarantees, but that enables them to have massive write throughput. Most of the time, I would advise using ClickHouse if you have data in append-only mode most of the time. Old versions are replaced when they are merged. When you merge the parts, the old versions are replaced. So that's, yeah. Also, when you create a table in ClickHouse, you will give them a clustering key. It's not a primary key, because there is no uniqueness constraint, but it will sort the file during, using that clustering key columns. So data are already sorted, which enables sparse indexing. So sparse indexing is basically the same as brain indexes. Instead of having an index for each value, we have indexes for a range of value. So for example, 1 and 3 per, that's not an example, that's exactly how it works, 1 and 3 per 8 kilobytes of rows with minimum and maximum value for the clustering key each time. But there's a caveat. ClickHouse won't start if the indexes that do not fit in RAM. So, yeah, I turned ClickHouse several times because of that, because I was very greedy with my indexes and sorting key. So, yeah, be very careful about that. Again, data are stored by column, not row. There's a better compression ratio, like 20 to 40 times. And the compression is quite fast. They are using common algorithm, common used algorithm, and it works great. If you want better compression for Postgres, I would advise to look at ZFS as a file storage system, because you are able to have great compression ratio using ZFS instead of XFS or PCRFS. So, it's an architectural choice. The index is always in memory, meaning that you need a huge amount of memory. If you need a huge amount of memory, it means that it will scale vertically, not horizontally. So it's best for non-dataset size and also enough memory budget, because you will need to buy some memory. Let's talk about the second one, DuckDB. So it's also an open source columnar OLAP database, but the difference is that it's in process. There's no server. It's running inside your application. And it handles larger than memory workloads, which is important. So it's very different because it's kind of a library that developers can use. So here is how it works. Inside the operating system process, and then it goes to storage using the regular I/O. The advantage of that is that you have no network layer, no network latency. You have shared memory with your application. You have also drawbacks. Like most of the time you have only one logical client per connection, and you can't have a lot of connections to that engine. So I wouldn't advise to use it for a multi-client web application, but it's good for data science, batch processing, and embedded analytics. You can also, if you're afraid that it will tank your application because it's using too many resources, you can set the resource limits so that it does not use too much memory or CPU. It's using something called vectorized processing. So vectorized processing means that it will read a chunk of 2048 rows. From that, it will create what we call a vector. A vector is a representation of the data, like we use in AI, in pgvector and so on. And then, to filter the data, it will just create a bit mask, which is very fast to do. And then, if you need aggregation, then it can aggregate on selected rows and repeat for the next chunk of 2048 rows. So you might ask yourself, what is this magic number, 2048 rows? Actually, that's an amount that normally fits in L2 cache for CPUs. So it's very efficient. And also, it's friend with SIMD, and so it's how a compiler auto-vectorizes dense arrays. So normally, that's a good value, and that's why it was checked for. It works with good hardware, and it's also friendly with the compiler. As I said, it runs inside the application. So let's talk about ACID. So Postgres is fully ACID. ACID capabilities are atomicity, consistency, isolation, durability. And this, as we've seen, MVCC, which is part of the isolation and almost part of the durability, comes with an overhead of 23 bytes per row. ClickHouse is not ACID. So there is no transaction. Each insert is immediate. There is no isolation. Readers can see partial writes. As we already said, it's very costly to update. It's also very costly to delete if you don't delete the whole table. But it has fast inserts. So the trade-off is speed for safety. It's perfect for logs or any data you can recreate from files. I wouldn't use that for financial data, for example. DuckDB, it's ACID, but different. So atomicity, transactions are all or nothing, so that's OK. Consistency constraints are enforced. And then isolation, we have snapshot isolation, but durability, we have lazy checkpointing, meaning we can lose some data. Not all of them, but something around 2 seconds can happen in case of crash. So Let's say a team of developers decides to go to ClickHouse for analytic speed, and they say, it's okay, we don't need ACID properties. 6 months later, how do we fix that corrupted record? Well, that would be difficult. You can't retrofit transactions into ClickHouse. You must reload the entire dataset from transactional, and as it's analytics, that can be huge. So there is a hidden cost. Yes, it does perform greatly, but there is some operational complexity. And then it reminds me of something. Well, when they said to us, MongoDB doesn't need ACID, we'll handle it in application code. And we've seen the disaster it was. Actually, in 2015, MongoDB finally added transactions. Because yes, you have fast insert. Yes, you also have data corruption after crash. And yes, bugs in app can cause inconsistency. That's a definitely yes. So I would be cautioned about saying, I don't need ACID for my database. Now, let's talk a little about benchmark. I won't show you any number, and I think it does not matter. So, benchmarking is hard. Benchmarking one system is possible. Benchmarking multiple systems fairly, that's way more difficult. It means that it requires an expertise in each system. So you need ClickHouse experts who know how to merge tree, you need DuckDB experts who understand vectorization, you need PostgreSQL experts who know tuning, you need time, budget, and most of all, you need no bias, which does not exist. So meet ClickBench. So ClickBench is kind of recognized as the go-to benchmark tool for analytics nowadays. There was this old standard from the 90s, TPCH, but it's very old and not very practical, where the ClickHouse team did a great job at trying to create a benchmark that could be reproduced over several engines. So it's maintained by the ClickHouse teams. They don't hide behind some kind of foundation and so on. No, they say it's us. It's transparent. Everything is public, reproducible. They gave you exactly the AWS hosts they use to perform their benchmark and so on. Fair, well, it's as fair as a team can be for their own system. I will never say my children are ugly, but some other people might think so. It's not a criticism, it's human nature. And of course, the ClickHouse team optimizes benchmark to show ClickHouse wins, because that's part of the game. So let's see how they configured Postgres. So for shared buffers, they decided to use 1/4 of the memory, which most of the time is a good setting, but their justification is the one written, so it's the commentary that I found interesting, is they have no idea why they put 25%, other than RDS is doing that by default, that must be good. So again, I understand it's difficult to be, it's not possible to be an expert in several technologies, but here it shows a lack of understanding on how it works. This is even worse for the max worker processes. So they kind of understood it was linked to parallelism, but their comment suggests that they have no idea what they do, so they added a small buffer of 15 just in case. And that's all. There's no more setting for Postgres. Well, they increased a little workman, but that's all. If they had simply used a tool like pgtune, they could have had a way better tuning for Postgres. But it's not on them. The main culprit is Postgres, because Postgres is bad at marketing. If Postgres was good at marketing, we wouldn't have only one PostgreSQL. We would have PostgreSQL Analytics Edition, pre-tuned for all app workload, PostgreSQL Transaction Edition, optimized for LTP, PostgreSQL Web App Edition, balanced for typical use, Postgres AI Edition, and so on. We would have several Postgreses with each their settings tuned for this purpose, and also maybe with shipped extensions. You could have PostgreSQL Geographical Edition with PostGIS included, and so on. So the problem is not them, it's on us, because we are very bad at marketing. So what we actually have, a multipurpose tool. You have knobs to turn, but don't trust the defaults. And so it's a feature, because you can tune it for everything. It's very multipurpose, and it's great. It's also a liability, because not so many people in this world know what they are doing when they are tuning Postgres, which is a real problem. I've heard several times people saying, oh, Postgres is not good. We can't make it work as it was working before. We will go back to Oracle. And then I arrive, and in less than 2 hours, I tune the Postgres, and it's running fast. It's just really a problem that I think the community could make better. So, if we look at ClickBench, which has the merit of existing, what does it show? ClickHouse and DuckDB win. PostgreSQL wasn't tuned, and columnar bits row-oriented. But what doesn't it show? It doesn't show what a properly tuned Postgres can do, and it doesn't show you if your workload actually looks like ClickBench workload. And operational complexity or total cost of ownership are masked. What I mean is, if you have a team of 3 people and you're already operating 6 different databases, you're in trouble. So, well, if you shouldn't have too many database technologies depending on the number of people able to operate them. Also, about the workload, ClickBench only works with one table. It's a huge table, a reasonable table, and no other client connections. That's where Postgres is good, when you have several connections, but you can't test that. So I just isolated 4 queries that could be made better so that you understand the kind of queries the ClickBench is throwing at Postgres and how we could make it better. So here, or if it's really realistic to do so. So here, we have 3 columns, a sum, a count, and an average. And even though it does make sense to have an average of resolution width, summing an ID does not seem like a great ID or something that we do every day. And of course, Postgres loses at that kind of aggregation because Postgres will read the entire row to some 3 columns. So that's a lot of I/O waste. If you have 20 columns in that table, then you will have to read all of them. Whereas ClickHouse will only read 3 columns. So regarding the benchmarks, that's 25 less I/O, which is important because we know that I/O is particularly slow in IT world today. Then we have this one, the high cardinality group by. Again, that's normally not something we do. Well, it could be done, but having a group by on user ID, we can get there are a lot of user IDs. So if you group by user IDs, you will have a lot of rows. And so as Postgres has to order them, it will overflow workmem, so it will spill on disk. This is particularly slow. This is why Postgres in that query is not good. And ClickHouse, using columnar group by, and the hash table stays in memory, does not have to swap on disk. So it's very, very fast to achieve that. That one is very interesting. We have a temporal filter here. And this would be perfect if Postgres had brain indexes, because it would be able to read so less, having so less I/O than it has now. It could skip 99% of pages, so it could compete. But ClickHouse decided that manual creation of other indices is not recommended, although if the system creates indexes automatically, it is considered okay. So their system is creating index automatically, that's fine, or is not, so it has no index. That seems a little unfair to me. I mean, if you want to, I understand that you shouldn't tune specifically your engine for one query to succeed in the benchmark, but not allowing Postgres to create indexes seems a little extreme. Then we have the vectorization gap. That's where DuckDB can win. So again, you can question if this is something that you would really do, like summing resolution widths with something and doing that more than 90 times. Not sure. But when you have vectorized execution, then and you process more than 2,000 rows at a time, that it's very, very easy. As Postgres does row-by-row execution, that is very slow. And then, of course, Postgres sucks at that kind of test. So, ClickBench, in fact, measures a specific workload. It wins because it measures the workloads it was designed for. Again, we've seen that Postgres was not designed for that. If Postgres was competing against other row-level engine, it would be good. Well, if it's tuned correctly, again. With bad tuning, you can't achieve anything. Actually, it's not a flaw in ClickBench, it's honest. And the real question shouldn't be who wins ClickBench, but more, does your workload look like ClickBench? Because it's not because ClickHouse and DuckDB are winning at ClickBench that it will be better for your own workload. And also remember, there are some caveats at using those technology instead of a more standard ACID technology. So, what do we do? The first thing is to understand the trade-offs. Nothing is free in this world. If you want to go fast, you have to deactivate some securities. Or you can say that I want the securities, I will just go on with the performance I get. You should measure your query times on real data. That's really important, because as Tom Kite says, all benchmarks are liars, because no benchmark is using your real data. And I would guess that if you try on your real query, with real data, then you should be able to know if that's a problem, if the query times are acceptable or not. My rule is that 95% of the use cases, PostgreSQL is good enough. Of course, if you do tune it correctly. And critically, if your team already knows Postgres, which they should, of course, there's zero operational overhead. And you have no idea how much it costs a company to have operational overhead. I've been at a company where I was a DBA for 3 technologies. So Postgres, Oracle, SQL Server. the context switch is very, very tiring, and on top of that, you're not that good in each technology because you can't follow the innovation on so many technologies. So, when you actually need to switch is only when you hit real walls. So, queries are regularly too long. Data ingestion is regularly too long. Data sites demand specialized compression. And you already tuned everything you could. Again, about the compression, look at the FS, it's great. So, if you have all that, normally the decision should be obvious to you. But until then, the best database is the one you already understand, because operational simplicity beats marginal performance gain. That's all for me. I'm open for questions.
Thank you. And questions? Oh.
Thanks, Lætitia. I fully agree with where you're going. I was just wondering, from your perspective, proper data modeling that understands the issue of columnar versus row, right? So for example, if we do a star model, where we significantly reduce the width of the rows, right?
Yes.
To deal with the I/O problem. I'm a little bit surprised that you're not harping more on that, because you see too many denormalized tables that become these super wide things that are actually working against Postgres' strength.
Yes, that's also one point. Of course, as Postgres is a relational database, you should model your data, and modeling for analytics is quite different from modeling for transactional. So, and the ClickBench example is only using one huge table, which is totally denormalized. So that's also one point where it does not help Postgres. Again, I'm actually pleased to see that Postgres does not perform that bad regarding how many obstacles it were given.
Thank you for the talk. Regarding the columnar versus row-based storage, but also compression, Timescale, I think, can do column-based storage.
Yes.
Also, it's pretty good with compression. So I was wondering why you didn't mention that.
Because it's not an open source tool. Okay. Well, Timescale is an open source tool, but I think that is part of the commercial version.
Yeah, okay, thank you.
And Crunchy does the same. Crunchy has an extension that does columnar storage for Postgres, but it's a commercial tool. And I wanted to compare open source tools.
All right, Lætitia, thank you so much for your talk. It's absolutely brilliant. You hit literally like each bullet point that I've been like cross-aiding for a while recently. Just one thing also kind of to add, to chime in for all of your ideas. When you say that ClickHouse workload is not necessarily your typical workload, I would say it's nobody's typical workload because working like in the midst of industry with all different demands around me, my conclusion that 95% of the cases, the world is hybrid. And there are very few, Mark, to your point, like real use cases of the like fact dimensions table star diagrams. The world is hybrid, and most of analytical queries need much more than select sum of whatever, lots of correlated queries and such. So in this respect, yes, yes, and yes. Thank you so much.
Thank you.
Other questions? Okay.
Yeah, so I think some people mentioned some technologies which are already based on Postgres and they support columnar. I wonder what's the direction in the open source community for Postgres?
There is a patch.
Also, does Columnar always come with the constraint that data must be immutable in general? Or?
No, so it's not basically immutable, but it's more difficult to update a whole row, as you can guess. But there is a patch and they are actually looking for contributors. So you can go to the hackers mailing list and search for columnar storage. You will find them. And they have a POC working, but they need more contributors.
Thank you.
Further questions?
You mentioned that the competitors to Postgres are memory-based, so they keep all the data in memory. Doesn't even that rule them out entirely right from the beginning? Because if I think about the analytic use cases that we have, they typically use huge amounts of data.
Yeah. So what you can do, what you could do to mimic them, in particular ClickHouse, you could reindex the index, so create an index, reindex it, so that you have the data in memory. And if you can do an index scan only, then you would be on the same equality level. But that means that you have to reindex before to make sure you are in the cache. But that's something I thought of. Sorry about that.
Yes. Oh.
Just to clarify one thing, so DuckDB doesn't keep everything in memory.
Sorry?
DuckDB doesn't keep
No,
everything in memory.
DuckDB no,
Just to
but
clarify this
ClickHouse
kind of
does
point,
keep
yeah.
things in memory. Well, indexes.
But generally, so see, I had a bit kind of difficult because you raised many interesting points, but also a little bit the main message came only essentially in the end, because you had to think that essentially 95% of the cases Postgres is sufficient and in 5% not.
Yes.
And I fully agree with this kind of message, but there is this kind of 5%, and I think that is a kind of target of most of this kind of, more columnar story-based kind of approaches. Even timescale and ClickHouse, that is the market we're going after, because there are definitely kind of use cases which are actually very popular, like if you go to high-frequency trading and so on, there's no way you can do this with Postgres.
Yes.
Pure technology.
And that's
also
great.
Still far away, because you see on the columnar storage level, that's only half of the story. And the other half is really the executor level in Postgres. And there, I think there's still a lot of work to be done in this direction.
Yeah, so I totally understand that. I agree with that. There are some, it's just that when, they say in medicine, when you hear hoof picks, you don't think of zebras. So the idea is that if you, too many people think that they are in the 5%. If that was true, it wouldn't be 5%. So the idea of using this 95% number is just to make people think, am I really in that case? Because, it's fine to be in that case, and it happens, but it's only marginal. So first, you need to decide if you're there, if you're really in the exception use case, or if you're in a normal use case, and there are things you can do to make things better.
Okay. Any last question? Well, I don't see any questions being raised. In that case, thanks a lot for your presentation. It was quite informative, and here's a small gift from the organization.
Thank you.